Hello, welcome to class. So today we are considering redox reaction. And redox reaction in chemistry means reduction and oxidation reaction. So reaction that has to do with charged species, charged molecules or charged atoms. Once they are reacting together, that reaction is called redox reaction. So you find this kind of reaction in electrolysis, and you find them in when we are separating compounds, so ionic compounds. So these kind of reactions are, most times we want to balance them. So in balancing redox reactions, we balance not just the atoms now, we also balance the charges. So we balance the charges also. So what are the charges here? We have the ionic, the negative charge, the positive charges, and all that. So we balance them both on the right side and the left side. So the net charges on both the right hand side and the left hand side must be balanced. Right? The reactant side and the product side must also be balanced. And when we are balancing this reaction, the question in most cases, theoretical questions in most cases, is always what is the, the question is always write a balanced chemical equation of the redox reaction, or write a balanced reaction of the redox reaction given. So this, for example, is a question that can be given maybe in WAEC and in NECO or any other examination, theoretical exam, maybe even in the first year 100 level. So this kind of question is always common. Now, how do we solve this? When we are solving this question, we look at it and select the species that are closely related. For example, when we say species, let me quickly mention that species are not just common in, we don't use the term species only in biology, we also use it in chemistry. So species generally as a term simply means the materials or organisms or compounds that are closely related. So now, what are the closely related species here? Now, we look at manganese. So manganese, we are solving it now. So manganese, tetraoxomanganese 7. This is tetraoxomanganese 7. So tetraoxomanganese 7 is closely related to manganese 2 ion. So tetraoxomanganese 7 is related to manganese 2 ion. So this is a reduction half. So we call it a reduction half. So because it's undergoing reduction, this is the species that is undergoing reduction. Manganese is undergoing reduction. Because it's undergoing reduction here, we separate it out, we write the half of it. Then we also write the next one, which is thin 2 ion. So thin 2 ion is related to thin 4 ion. So this is the first step. So in this channel, we are simplifying things and we break everything down step by step, so we can understand it perfectly. So this is the first thing we do. Then we neglect the hydrogen ion if it's standing alone. If hydrogen is standing alone, you have to neglect it. You leave it first. You keep it aside. So we are not considering that. Then if water molecule or oxygen is standing alone, you keep them aside. So we are not considering that. So the main species are what we are going to be considering. So we are considering tetraoxomanganese 7 and tin. So tetraoxomanganese 7 and tin is what we are considering on both sides, left hand side and the right hand side. So while this one is undergoing reduction, this is undergoing oxidation. So what do? We, after breaking the species this way, now we will make a line this way. Now when we make a line, the next thing we are going to do is to now balance the individual atoms for the reduction half. Now tetraoxomanganese 7 and manganese 2 ion. So we have one manganese here, we have one manganese here. So manganese is balanced, no need of balancing that now. So but here we have 4 atoms of oxygen here, and here we don't have any atom of oxygen at all. We don't have any oxygen on this side. So we must create one here so as to balance both sides. So how do we do that? Now, rule number 1 says that rule number 1. So I call it rule number 1, so we can easily understand it. Rule number 1 is that you balance oxygen with water. So what it means is that for every oxygen, we must balance it with water. So if we have 2 oxygen, meaning we are going to balance with 2 molecules of water. If we have 3, we balance with 3 molecules of water. If we have 4, we balance with 4 molecules of water. So in that order. So here, we are now going to balance this side. Now, manganese, like we said, is balanced already. Manganese is 1 on the left hand side and is 1 on the right hand side. So manganese is here. So we have manganese. Then is giving us Mn2 plus. Now you have 4 atoms of oxygen on the left hand side. So on the right hand side, we are going to use 4 atoms of water. I mean 4 molecules of water. So 4 molecules of water is what we are going to use to balance it. So this side is settled now. Now the next thing, but when we are trying to balance the oxygen, when we balance it with 4 atoms, 4 molecules of water, we have introduced hydrogen into it now. So the hydrogen that is introduced here is not on this side. We have to now come to the left hand side again and balance the hydrogen here. Then how many atoms of hydrogen do we have here? We have 4. I mean we have 8. 2 times 4, 8. So we have 4 atoms of hydrogen here. So if we are balancing hydrogen, rule number 2 says that, rule number 2, it says that balance hydrogen with proton or hydrogen ion, that is H plus. So we are balancing hydrogen with hydrogen ion. So we have 8 hydrogen on this side. So on this side we must introduce hydrogen ion to it. So how many are we introducing? We are going to introduce 8 of it. So this is how we are going to take that now. So MnO4 minus plus 8H plus giving us Mn2 plus 4 molecules of water. So having written it this way now, we are done here. Let's now move on to 10. So the second observation half is 10. So we write the 10 now. So 10, we have 1 atom of 10 on the left hand side. We have 1 atom of 10 on the right hand side. So nothing more to balance here. So we just write the 10 here, 2 plus, to give 10, 4 plus. So this side is settled now. Now the next thing we are going to do, having done this now, is to now balance the charges. We have balanced the individual atom already. The individual atoms are already balanced. So the next thing we are going to do is to balance their charges. Now, to balance the charge, let's now know how many charges we have on the left hand side and the right hand side of the reduction half. So this is how we are going to do it. So MnO4 tetraoxymanganate 7 plus H proton is giving us Mn2 plus 4 molecules of water. So because we have this now, how many charge we have on this tetraoxymanganate 7? We have just 1. So we have 1, we say minus 1. Then plus how many charge we have on this proton? We have 8. 8 times plus, so that is plus 8. So on this side, we have just 2 charge on manganese, so it's plus 2. Plus on 4 molecules of water, we have 0 charge, so we don't have any charge on it. So minus 1 plus 8 is plus 7. Then this one is plus 2. So meaning that we have 7 net charge here. and we have 2 charge here. So this I have the greater number of charge and this I have less number of charge. So that takes us to rule number 3. So rule number 3 says that we should balance charge with E minus. So we remove electron from the side with the higher number. So when we are balancing it, we don't add it to the small side, we add it to the bigger side here. So this side that is the larger part, this side has 7. So we are going to put it on this species, the left hand side of this species, and of this reaction rather, and remove 5 from it. Because if we remove 5 electrons from it, we are going to have 2. So that is how we are going to write it. So the next thing we are going to do now is to write it. We say Mn tetrahydromanganese 7 plus 8H plus we now remove 5 electrons from it. So it's going to give us manganese 2 plus 4 molecules of water. So this is that is for this one now. Then we now move on to the next part. So the next part is to now consider the oxidation half. So the oxidation half is 10. So of course 10 is 2 giving us 4. Now, if we want to know the number of charge on this side is just plus 2, obviously, as we have it on top here. So it's plus 2. So we have plus 2, and this side is just plus 4. So it means the right hand side is larger than the left hand side. So what do we do according to rule 3? We remove the charge. We are balancing the charge with E minus. So we are going to remove the charge from this side. So we are going to write it this way now. So we say T 2 ion giving us 4 plus we remove 2 E minus from it. So 4 minus 2 will be 2. So it's going to be plus 2 plus 2 now. That is how it is written. Now after writing this, now we now bring both of them together. We are going to bring the oxidation half and the reduction half together. So we bring them out this way. So I'm going to write MnO4 minus plus 8H plus 5E minus to give Mn 2 plus 4H2O. Now, this is the first half, the reduction half. Then let's bring the other half. So this one is thing 2 giving us SN4 plus 2E minus. So we have brought them together now. Now that we have brought them together, the next thing we are going to do is to now eliminate the electrons. We are not going to show it in the final analysis. We are not going to show it in the final balance equation. So we have to look for a way to eliminate them, and that is where mass comes in. So we bring elimination method in mathematics to rescue it now. So you look for a way to make sure the electrons are balanced and cancel them out. So how do we do that? On the reduction half, we multiply it by 2, while the oxidation half, we multiply it by 5. So if we do that, you will see that the electrons will be 4, then we have to cancel them out. So now the next step we are going to take now is to now multiply both sides, multiply the top first, so by 2. So 2 will multiply tetrahydromanganese 7. So 2 times tetrahydromanganese 7 will be 2 molecules of that plus 2 times 8 proton will become 16 proton plus 2 times 5 electron become 10 electron. Then we give us Mn manganese 2 plus, sorry, we multiply it by 2 again, so this becomes 2mn, 2 plus 2 times 4 becomes 8 molecules of water. So this is what we are going to do. That we sort it out. Then after that, on this side now we are multiplying everything here by 5. So this becomes 5 tin 2 will give us, this becomes 5 tin 4 ion to give us plus 5 times this one becomes 10 E minus. So you will see that the 10E is equal to the 10E on the 10E on the reduction half is the same thing as 10E on the oxidation half. So we can now strike them out. We can cancel them out now. So we cancel them out this way. And before you can cancel them, for you to know whether what you are solving is correct, they must be on the opposite side. You will see that this 10 electron on this side is on the left hand side, while the 10 electron on this side is on the right hand side. So if they are on the same side, means what you are doing may not be okay. So you have to look at it very well. So this side has been sorted now. Now this is done now. We are about rounding up now. So the next thing we are going to do is just to now condense the two equations together. Now condense the two halves. You know we have split them into half before. So we condense them into the same equation now. So we are bringing them together. So if we are bringing them together, we now use the templates. You can write it as it is, but you use the template here. Okay, first of all, let's just write everything on the right hand side together and write everything on the left, everything on the left hand side together, and later write the other one, everything on the left hand, on the right hand side together. So this is what I mean now. So here we write 2 molecules of the tetrahydromanganate 7, then plus 16 H plus, of course 10 has been cancelled. I won't write again, so I will come to this side. This is the next one I'm writing now because they are on the same side. So I'll write plus 5T 2 ion. Now the arrow will now point to this side, which is giving us, I write this first, so 2 manganese 2 ion plus 8 water, 8 molecules of water. Now the 8 molecules of water plus what is on this same side is tin. So I write 5 tin. So 5 tin. So I write the 5 tin. Now, for us to make sure that everything we get, this one is balanced as it is now, but since they are giving us this equation to balance, we must now arrange it to, we must use this template, we must use it as a template to arrange our equation. So what I mean is, we arrange the molecules in order of, we pattern it in order of this one, so the way they do it, so that we can satisfy the examiner very well. So now we now write this manganese. The manganese comes first. So the manganese atom, that is tetrahydromanganate 7 comes first. So we are going to write 2 MnO4 minus plus, after that is the tin. So I'm going to write the tin next now. So 5 tin 2 ion plus, after that the next thing I'm writing is hydrogen. It's hydrogen. So I'm writing 16 hydrogen ion, then which gives manganese comes next. So the manganese ion plus, next thing is the tin. So I'm writing the tin next, 5 tin. Now followed by water. So we have used this one as a template now. So we will now write the water, which is 8 molecules of water. So we are writing that now. So we have 8 molecules of water. Now, having written that, the next thing we are going to do now, this is already balanced. So this is the balance equation. This is what the examiner wants to mark. So if you are written it correctly like this, the examiner will give you your full mark. So whether at WAEC, level, NECO, or first year in the university, you have gotten your full mark as this. So then the next thing we can do now is to now do a check. So we check if we are correct. So we perform a check. So if you want to check whether you are correct, you check for each of the atoms. So the atoms of each of the elements here, atoms of the molecules or the ions here on the left hand side and the one on the right hand side, everything must be the same. So we have 2 manganese on this side, we have 2 manganese here. That is correct. The next thing is for oxygen, we have 8 oxygen on this side. We have 8 oxygen on this side. Now for tin, we have 5 tin on this side. We have 5 tin on this other side, on the right hand side. Now we have 16 hydrogen here, hydrogen ion or 16 proton. Then we also have 16, 8 times 2, 16 hydrogen on that side. So that means what we have done is correct. Then what about the charges? We must also balance the charges. That is why redox reaction is different from the regular chemical equation. Here we just balance only the atoms and go. But here we must balance the charges also. So for the charges, we now look at the charges here. So the charge here, 2 times minus, so that is 2e now. So we have minus 2 here. So minus 2 is the total charge on this set of the manganese now, not just 1 now, because there is 2 here. So 2 is the coefficient here. So 2 multiply this, is multiply everybody. So 2 multiply this by 2e, 2 minus. So there is 2 charge here now. Then plus, what is here? 5 times 2. 5 times 2 is 10. So we have plus 10 is positive. So you must ensure that you write the either negative, either it's a cation or an anion. So you must indicate it here. So this is a cation. So 10, I'm writing 10 now. So we have plus 10 here. Then the next one is 16. So I have plus 16. So that is the next charge here, 16. That is 6 times this plus. So 16 times this plus, so 16 charge. So what about this other side? So this side, 2 times 2 is 4. So we have 4 plus 4 here on this side. Then on this side also, we have 5 times 4, which is 20. So it's plus 20 on this side. Then plus for 8 molecules of water, we have no charge on it. So it's 0. So it's 0. We write it this way. Now let's now calculate it together. So minus 2 plus 10 plus 16. This is plus 24. So you have minus 2, you have 10, that is 8. 8 plus this, that is 24. So plus 24. Or you simply say 10 plus 16, which is 26. 26 minus 2, that is 24. Plus, that is plus 24. On this side, obviously, plus 4 plus 20 is simply 24. So it's plus 24. You will see that both charges are also balanced. So this is how you confirm whether what you have calculated is correct or not. So if at the time you are solving it is not balanced this way, then you should know that your calculation is not correct. So in your WAEC, in your NECO, in your IGCSE, or any theoretical exam that require you to write continuous one where you have to show your workings, this is how you show the workings. You may not write the check, you can solve the check somewhere and just show it, but this is your final answer for this. Then in JAMB, what does JAMB ask in this kind of a scenario? Usually JAMB will ask you for a missing number. I will solve a similar one maybe in the next video, so you will see it, where a missing variable will be there. They will use S to indicate something and tell you what is the value of that S or what is the value of N. So that's what you're looking at, because in JAMB for UTME, you usually do not have to solve, you don't have theoretical questions, so you are just giving multiple choice. But that multiple choice, you must be able to do one of calculations somewhere before you arrive at the answer. So that is how it is. So we are going to show that. So if you like this video, please like, share, and subscribe to this channel. Then drop your comment if you have any comments. I'm checking the comments. Then I can respond appropriately to your questions, so or your comments as the case may be. So Thank you for subscribing. Thank you for liking this channel. So remember to subscribe. Thank you.